So far, we have studied the configuration of a capacitor where in between the plates there is a vacuum. So now let's start from the dielectric, and we will see the effect of dielectric in the capacitor in this lecture. So we know the dielectric is a non-conducting material, and most of the capacitors have a dielectric between the conducting plates. Most of the capacitor, mylar is used. It is a plastic sheet which is used as a dielectric material. There are few benefits of placing dielectric between the metal plates. First one is it is very difficult to maintain a small separation without contact between the plates of the capacitor. So with the help of dielectric, the distance between the two, the separation can be maintained. Maintain the separation. Second, it increases the potential difference between the capacitor plates. How it is going to increase that? Plates. Okay. Insulating materials, when they are placed under a large electric field, there is a partial ionization takes place in that. Because of that ionization, uh, these insulators break down, and electricity or conduction can take place between the from the dielectric. This breakdown or this ionization under the effect of large electric field is called dielectric breakdown. Many dielectric materials have this tendency to tolerate the stronger electric fields without breakdown. So because of this strength, they allow a capacitor to sustain a higher potential difference, and a greater amount of charge and energy is stored. Okay. Third benefit to put the dielectric between the capacitor plates is it increases capacitance of the capacitor. For a specific dimensions of a capacitor, the capacitance becomes higher when the dielectric material is placed between the plates. For example, there is a vacuum at the moment, but if there is some dielectric placed in between these metal plates, then the capacitance becomes higher. Experimentally, this effect is discovered with the help of a very sensitive device, electrometer, electrometer helps to measure the potential difference between two conductors. So when there is no dielectric medium, the potential difference was showing some value, let's suppose 5 volts, and when we insert dielectric in between, the electrometer flips to the other side, which shows that the value of the potential difference changes, and when the value of the potential difference changes, the value of the capacitance also changed. This experiment was conducted several times by using different sheets of different dielectrics, and the effect was, we know from the basic relation, we know that capacitance and potential difference are inversely proportional to each other. So if the capacitance increase, it means the value of the potential goes down. So when we insert a dielectric medium inside the plates of the capacitor, the value of potential reduced. Okay, let's suppose we have a original capacitor without in a vacuum, and that capacitance has capacitance C naught. Okay, 0 mean original. O. So C naught is equal to Q over V naught. And the capacitance with the dielectric, when we insert the dielectric here, the capacitance becomes C is equal to Q over V. The value of the charge is same in both, and we know that when you put the dielectric in between the plates, the value of the potential becomes less, so this becomes low as compared to the original capacitor, which was high as compared to this. So we can conclude that capacitance with the dielectric presence is greater than C naught. So at this moment, when there is a dielectric in between the plates, the capacitance is higher. So C is higher as compared to C naught. Okay. Now if the whole space between the plates is filled with this dielectric medium, then ratio of both capacitance becomes equal to it over V, and it is equal to the dielectric constant. For every dielectric there is a specific value of the dielectric constant, and so in terms of potential difference, we know it shows that potential difference is reduced by factor K. A capacitor who has a dielectric medium having a potential difference V is reduced by a factor of K. So other thing is, when we put a dielectric, the capacitance or C is always greater than C naught. It means that K is always greater than unity. For vacuum, K is equal to 1. For air and at ordinary temperature and pressure, it is slightly greater than 1.006, nearly equal to 1. For so sometime instead of vacuum we can also use air as a medium in the capacitors. Okay, so because potential is potential and V are and E are related to each other, it means if the potential is reduced by a factor of K, the electric field of the the electric field also reduced by a factor of K. So this relation can be written in the term of electric field as is equal to E naught over K when charge is constant.